Get ready to look up again because one of the year's best sky shows is about to light up Georgia's night sky.
That's right. Show meteorologist Danielle Moss is explaining the best time to catch the Perseids Meteor Shower in tonight's Weather Extra.
Have you ever wanted to wish on a star, like a lot of stars? Well, grab your blanket and a snack, and definitely some bug spray, because the Perseids Meteor Shower is about to put on one of the most dazzling sky shows of the year. It's got everything: drama, sparkle, and a cosmic backstory that's out of this world. These meteors are actually bits of an old comet that will come crashing into our atmosphere at 130,000 miles per hour. They streak across the night sky, lighting up like nature's own fireworks show. Some even leave glowing trails like they know they're showing off. The Perseids show up every August, but they hit their peak mid-month in Georgia. That's August 12th overnight into the 13th. That's when you could see 50 to 60 meteors per hour. That's a wish every minute if you're keeping count. No telescope, no problem. All you need are your eyes, a dark sky, and a little patience. Best viewing time? After midnight. Best direction? Look northeast. That's where they appear to radiate. The best part? These shooting stars aren't just pretty, they're tiny pieces of space history burning up in our skies like a cosmic goodbye. This is a great excuse to stay up late and catch a streak across the sky, so don't blink.
Two of the brightest objects in the night sky, so it's basically impossible to miss, and this is perfectly coinciding with the peak of the Perseids Meteor Shower. So there was a comet that broke up into a whole bunch of fragments a long time ago, and we see the orbit and distribution of those fragments here, and once per year, there is a massive increase in the amount of meteors that we have coming in, about 1 per minute, originating from mostly the constellation of Perseus. And so tonight, if you go out, you will see Venus conjunct Jupiter starting about 3 hours before sunrise, and you also may see a whole bunch of shooting stars.
Welcome, curious minds, to the deep dive. Today, we're embarking on a bit of a cosmic journey. We're diving deep into one of nature's most dazzling annual performances, the Perseids Meteor Shower. Our mission, simple. We want to unpack the what, the why, and the how of this whole spectacle. Make sure you become instantly well-informed about, well, one of the most reliable events up there in the night sky. And here's something neat. If you happen to be listening to this on August 12th, 2025, you are perfectly timed, right on cue for the peak of the shower.
That's absolutely right. And prepare to be genuinely amazed, I think. We're going to pull back the curtain on some really surprising facts, and there's such a rich history here. We're talking ancient observations going back millennia, all the way to the science behind that dazzling display. And of course, we'll give you all the practical tips you need to actually enjoy the show tonight.
Just imagine it. Dozens, maybe even 100 meteors an hour streaking across the sky, leaving these glowing trails behind them. It really is like nature's own fireworks.
Exactly. But maybe grander somehow.
Yeah, grander and kind of personal. Okay, let's unpack this. So first things first, the really basic question. When we talk about the Perseids Meteor Shower, what are we actually seeing?
Right. We often call them shooting stars, don't we?
Yeah, that's the common term.
But what you're really seeing is Earth moving through this cloud of tiny cosmic dust. Particles mostly no bigger than, say, a grain of sand, maybe a small pebble. And they hit our atmosphere at these just incredible speeds, and they burn up brilliantly.
So it's an annual thing because we fly through the same debris field every year.
Precisely. Earth's orbit takes us right through this trail left behind by a comet, year after year.
Okay, and the name Perseids, that comes from Perseus, the constellation.
Yeah, exactly. Because if you trace the paths of the meteors backwards, they all seem to come from a single point, the radiant, which lies inside the constellation Perseus.
Yeah.
It's like perspective, like looking down railway tracks. They seem to meet in the distance.
Ah, okay. That makes sense.
And the Perseids, they have this great reputation. They're known for being one of the most reliable, most prolific showers. You can get Under perfect conditions, maybe up to 100 meteors per hour at the peak.
Perfect conditions meaning really dark skies, I guess.
Yeah, dark skies, no moon. That's the ideal.
And for 2025, you mentioned the peak is tonight, August 12th.
That's right. It's actually been active since mid-July and runs through late August. But the real main event, the highest concentration, is tonight, August 12th, and also tomorrow night, the 13th.
Okay.
And they're special for a few reasons, beyond just the numbers. First, they're fast, really fast. We're talking about 132,000 miles per hour.
Whoa.
Yeah. And because of that speed and their composition, many lead these glowing trails. We call them persistent trains.
Yeah.
It's basically ionized air glowing in their wake, can last for seconds, sometimes even longer.
I think I've seen those. They just hang there for a moment.
Exactly. And sometimes, if you get a slightly larger piece, maybe pebble-sized or bigger, it creates a fireball. A really bright meteor that can even cast shadows. Super spectacular.
Wow. So it's like the universe is just putting on this free, incredible late show.
Pretty much, just for anyone who looks up.
It's amazing. Which makes you wonder, how long have we been looking up? How long have people noticed this?
Oh, for a very, very long time.
Yeah.
We have records from ancient China. Around 36 AD, their astronomers wrote about seeing more than 100 meteors flying swiftly in the morning.
36 AD. Incredible.
Yeah, and there are European observations too, from as far back as the 8th century. Though back then they didn't, understand why it was happening.
Right, the science came much later.
Much later. It wasn't really until the 19th century that people started connecting the dots scientifically. There was a Belgian astronomer, Adolphe Swift-Tuttle, in 1835. He was the one who identified the radiant point in Perseus.
Ah, so he gave it the name.
He formalized the name, yeah. But the big breakthrough, understanding the source, came in 1862. That's when two astronomers, Louis Swift and Horace Tuttle, working independently, discovered the comet. Comet 109P Swift-Tuttle.
The source. So the comet is leaving this trail behind.
Exactly. Comet Swift-Tuttle is this massive ball of ice and rock, about 16 miles wide.
16 miles. That's huge for a comet.
It is. It has this long orbit, takes about 133 years to go around the sun. Every time it gets close to the sun, the heat makes it shed gas and dust, loads of it.
Creating this stream of debris along its path.
Precisely. Like a cosmic litter bug leaving a trail across the solar system.
And we just happen to fly through that trail every August.
That's the one. The comet itself last came by in 1992.
Oh, I remember that. There was a bit of buzz about it.
There was. It won't be back until 2126.
Wow, long time.
Yeah. But it's debris stream, that trail of particles it left behind that's still out there. And that's what gives us this amazing shower year after year, our annual gift from Swift-Tuttle.
It's kind of a cool thought, a gift from a comet. But I also read that this comet is actually considered potentially hazardous, like long term.
Well, yes, technically it is. Because its orbit crosses Earth's orbit, there's always a potential for collision way down the line. But NASA has crunched the numbers. They say we're safe for at least the next 2,000 years. Probably much longer.
Okay, good. So no need to panic tonight while watching the show.
Definitely not. It's just a fascinating reminder, though, isn't it? This incredibly beautiful thing comes from something that carries a tiny, tiny bit of cosmic risk. It's all connected.
That is a powerful thought. Beauty and risk intertwined. Okay, speaking of science, let's maybe geek out a little on the mechanics. How does this work exactly? Earth hitting comet dust.
Yeah, let's do it. So the basic idea behind any meteor shower is Earth crossing the orbital path of a comet. And comets, the image, they're often called dirty snowballs.
Right. Ice, rock, dust.
Exactly. Leftovers from when the solar system formed. Primitive stuff.
Yeah.
And that dirty part, the dust and rock, that's the key for meteor showers.
So Comet Swift-Tuttle swings near the sun.
Right, the heat causes the ice to vaporize, sublimate, really releasing all that embedded dust and rock. It forms this huge diffuse cloud or stream that follows the comet's orbit.
And then Earth comes along.
And Earth plows right through that stream every August, moving at about, 67,000 miles per hour in our orbit?
That's fast.
It is. And these tiny particles, the comet dust, slams into our atmosphere at even higher speeds relative to us. Remember the 132,000 mile per hour for the Perseids?
Yeah, incredible speed.
So that collision, that friction with air molecules, heats these tiny particles up to thousands of degrees. Instantly. They just vaporize in a flash of light. That's the streak you see. That's the meteor.
So the brightness isn't just the size, but the speed and the angle they hit us.
Absolutely. The high velocity of the Perseids is a big reason why they're often so bright and those persistent trains we talked about.
Okay. And what about this year, 2025? You mentioned the moon might be a factor.
Yeah, unfortunately the moon is a waning gibbous tonight, about 84% full.
Ah, so it'll be pretty bright.
It will be. And moonlight does tend to wash out the fainter meteors. It reduces the contrast. So instead of maybe seeing that absolute peak of 100 per hour, a more realistic expectation under these conditions, even in a dark sky, might be, say, 50 to 75 per hour.
Still pretty good, though.
Oh, absolutely still worth it. The American Meteor Society is still predicting a really solid show. The Perseids are bright enough that many will punch through the moonlight. Don't let the moon stop you.
Good to know. And these particles, what are they actually made of?
Mostly silicates, like rock minerals and some metals. Basically, tiny bits of primordial rock and dust. Stuff that have been orbiting out there since the solar system was young. Billions of years old.
Wow. So when you see a meteor streak, you're literally watching a tiny piece of ancient space history burn up.
That's exactly what you're saying. A connection right back to the formation of the planet. Pretty profound when you think that.
It really is. Okay, all right. Enough backstory. Fascinating as it is, let's get practical. For everyone listening tonight, August 12th, 2025, who wants to see this? How do they do it? What's the plan?
The great news is it's super simple, honestly. No fancy gear needed.
No telescopes.
No, definitely not telescopes or binoculars. They actually limit your field of view too much. You want to see as much sky as possible. Your own eyes are the best tools for this.
Okay, so step 1, ditch the telescope. Step 2, location.
Location is key. You need to get away from city lights. Light pollution is the enemy of meteor showers. Find the darkest spot you can. A rural park, maybe out on a beach, even just a backyard if it's shielded from street lights and house lights.
Dark adaptation is important too, right?
Crucial. Your eyes need time to adjust to the darkness to see the fainter meteors. Give it at least 20, maybe 30 minutes. And that means putting the phone away. The bright screen will ruin your night vision.
Good tip. No doom scrolling while waiting for meteors.
Exactly. Okay, so you're in a dark spot, your eyes are adapted.
Yeah.
What next?
How about timing? When's the best time to look?
The best viewing is generally after midnight, local time, and it gets better towards dawn. That's because the radiant point in Perseus climbs higher in the sky as the night progresses.
Okay, after midnight. And where should people look? Just straight up.
You can look straight up, but generally for Northern Hemisphere viewers, looking towards the northeast is good. Perseus will be rising in the northeast. But you don't need to stare right at Perseus. The meteors will appear all over the sky. They just trace back to Perseus.
So find a comfy spot and scan the whole sky, basically.
That's the best way. Lie back on a blanket or a reclining chair. It makes it much easier on your neck.
What about for people in the southern hemisphere? Can they see them?
It's tougher, yeah. Perseus is much lower on the northern horizon for them, or might not even be visible. But they might still catch some Perseids, especially Earth grazers, long, slow meteors that skim the top of the atmosphere horizontally. They can appear even before the radiant is high, so it's still worth a look.
Okay, any other pro tips?
Yeah, a few. Dress warmly. Even summer nights can get surprisingly chilly when you're sitting still for a long time. Bring snacks and maybe a warm drink. It makes the waiting more pleasant. Oh, and bug spray. Depending on where you are, mosquitoes can definitely ruin the mood.
Good call on the bug spray.
And if that bright moon is bothering you, try to position yourself so maybe a tree or a building blocks it from your direct view. It can help a bit.
Smart. Use the environment.
And finally, patience. Meteors often come in spurts. You might see nothing for 10 minutes, then 3 or 4 in quick succession. Just relax and enjoy the sky.
Maybe use one of those stargazing apps to find Perseus first, just to get oriented.
Yeah, that's a great idea. Apps like Sky Safari or Stellarium are perfect for that. Find Perseus, it's usually near that easy to spot W shape of Cassiopeia, then put the phone away and just look up.
Awesome. So, summing up, dark spot, after midnight, look northeast-ish, but scan wide, be patient, get comfy, no phones, maybe bring snacks.
You got it. Sounds like a plan.
Weather permitting, tonight's the night, maybe grab some friends, make it a little stargazing party.
Absolutely. It's a great shared experience.
Okay, before we wrap this all up, let's touch on the sort of the magic and meaning. Beyond the science, what have these things meant to people?
Oh, that's a rich area. Shooting stars, and the Perseids specifically, have captured human imagination for, well, forever. In ancient Greece, for example, they linked the shower to their hero, Perseus. You know, the guy who slayed Medusa.
Right, hence the name.
Exactly. Some stories even suggested the shower was Zeus, descending in a shower of gold to Father Perseus with Danae. A direct link between the heavens and myth.
Wow. What about other traditions?
There's a very strong Christian tradition, particularly in Catholic cultures. The Perseids peak around the feast day of St. Lawrence. He was martyred, supposedly roasted on a gridiron on August 10th in 258 AD.
Oh, wow.
So the meteors became known as the Tears of St. Lawrence, symbolizing the sparks flying from this fiery martyrdom. A pretty intense image.
That is intense. So these lights became symbols.
Very much so. And not just in Europe. Many cultures saw shooting stars as omens or signs. Some Native American tribes viewed them as the spirits of the dead crossing over. In Japan, there's a long tradition tying them to good luck and wishes.
Which leads right to what we still do today, right? Make a wish on a shooting star.
Exactly. That saying is this incredibly old, persistent piece of folklore, a direct echo of that ancient belief that these fleeting lights somehow connect us to something powerful, something magical.
It's amazing how that sticks with us, even knowing the science.
It is. I think it shows that whether you look at it through the lens of science, cometary debris hitting the atmosphere, or through the lens of myth and symbolism, these events just resonate. They make us look up, they make us wonder, they remind us we're part of this huge, amazing cosmos.
A perfect way to put it. Science and wonder, hand in hand. Well, that feels like a good place to start wrapping up our deep dive into the Perseids Meteor Shower. It really is nature's reminder that the universe is just full of these incredible surprises, always there waiting for us to look up and explore.
Absolutely. And it's a shared human experience, isn't it?
Yeah.
People all over the world, potentially tonight, looking up at the same sky, seeing the same phenomenon. If you do catch the show tonight, really try to embrace that. Take a moment, feel that connection, maybe share what you see or just the feeling with someone.
Yeah, definitely. So here's a final thought to leave you with. What does it really mean that for thousands upon thousands of years, humans have gazed up at these very same streaks of light, these tiny ancient pieces of a comet? We wove them into our deepest myths, gave them names, imbued them with meaning, and then much later we dissected them with science, figured out the mechanics. Yet somehow, both perspectives seem to offer us this reflection of our own place, tiny yet connected, in this vast, ancient, and always unfolding universe. Keep looking up.